There are three equations that you can have with a line. In this case, we only have to deal with two. Vector equation and a parametric equation. With the vector equation, there are two pieces of information. This piece of information is a point on the line, or a vector pointing to the line. The second piece of information is the direction vector. This is a vector anywhere on the line that goes from one point on the line to a second. The second equation is the parametric equation. It's broken down from the vector equation into its x, y, and z values. First, it has its x, y, and z values from the point on the line, and then it has a t value and its x, y, and z values from the direction vector. In this question, there are two pieces of given information, the first point and the second point, which both fall on the line. So with our two pieces of given information, these 2 points on the line, we can get both our direction vector and the point on the line. Either one of these will work for the point on the line, so that's our first piece of information. The second is a direction vector. In an example here, you can see 2 points on a line. No matter which way you go between the 2 points, you'll get the direction vector. So we have to choose one of the points as a tip and one of the points as a tail. In this case, I chose point 1 as the tip and point 2 as the tail. You subtract point 2 from point 1, and this will give you the direction vector. So the x value minus the x value, y minus y, and z minus z. This results in a vector, and this is our direction vector. Now with both informations we need, we can plug in to the vector equation. The point on the plane can be satisfied by either of the 2 points you were given, and the newly solved direction vector will be the last piece of information. There will be two possibilities, as there are 2 points on the line that will work. 2, -3, and 5, which we chose to be our tip value, we'll use as our first point on the line, and our direction vector will stay the same for each. In this case, our vector equation reads xyz equals 2, -3, 5 plus t3, -7, 3. The second possibility is all the same, except the point on the line is -1, 4, 8, which is point 2, or the tail of our direction vector. Now we have to transform it into parametric form, which we did up here. So you have your x, y, and z values all broken down. You take the x values of your point on the line, and then a t value combined with your x, y, and z value of your direction vector. There are going to be two possibilities as you have 2 points on the line once again. The first possibility is x is equal to 2 plus 3t, y is equal to -3 minus 7t, and z is equal to 5 minus 3t. The second possibility is exactly the same, but once again you use -1, 4, and 8 as your x, y, and z values. So with these two final vector equations and these two final parametric equations, that's your answer.